I gave a talk on the same topic at a Scala meetup, so I'm really quite bad at actually pitching to the right audience. I'm Tom. I work at Habito. I work about there, like literally the other side of this ceiling. I write Haskell pure script, all that Will said. I tweet. I have a GitHub. There's my blog. At the moment it's Idris, but it'll probably be about this at some point, so if you're interested, carry on. So the first thing I want to talk about is what life was like before we had the virtual DOM. And I know I'm talking to Haskell developers, so maybe not everyone's worked with the web, the disgusting beast that it is. And in the good old days, we had jQuery and things like that. And if we wanted to update a web page, we would store a load of the interesting bits in global state, and then we would attach some event handlers, and we would take them away depending on what was happening. And it was all left to our intelligence to get it right. And this was disgusting, and it went wrong all the time. And not just like day to day. Huge architectural decisions are just made on kind of faulty and unstable logic, and it didn't work. For ages and ages and ages, we wrote websites with things like jQuery, mootools, that sort of thing, and then we got to Backbone, Angular, and kept trying. And then some clever people came up with the idea of the virtual DOM, which is pleasant to all of us as functional programmers, because it kind of boils down to three interesting functions. The first one is the kind of notion of rendering. So every time the state changes, I have this function from a state to a view. And all I do is apply that to the state, and I get the view out. Once I've done that, I look at what the view used to be and what it is now, and I work out the most optimal way to make that change. So I look at the differences and say, I've added this attribute, I've removed these three elements, whatever it is. And then I have a diff. I apply that to the actual DOM, the website changes. And anyone who's used Redux or Elm or anything like that probably recognizes the last one, which is how we do updates in the Elm architecture and things like that, which is you tell me something's happened, an event has happened of some sort, and you give me what the state was, and I'll use that to determine what the state will be. When I know what the state will be, I re-render, do the diff again, and everything works in a loop. And it's all great. And what it boils down to underneath is you have a DSL that represents your DOM. So you don't actually write HTML. You don't write DOM manipulating code. You write in this DSL, which we kind of label the virtual DOM, which roughly mimics what the DOM looks like. So here's my kind of basic example of saying an element has a name, so it's an A tag or a bold or whatever else people do, is some properties, an attribute map, so it's basically key to values. Some of those values might be functions, like onClick, and some of them might be strings, like class name. And then some children, so it's a big kind of rose tree, basically. And you can also have text, which is uninteresting and to get stuff on the page. And this is ugly, so what we did was we created helper functions to abstract this away so we didn't have to look at it. And this is something I stole from the Elm examples, I think, which kind of walks you through everything you need to know. We've got this div function here that takes an array of properties, in this case nothing, and then an array of children. We've got the button that takes an array of properties, in this case an onClick handler, and some children, in this case just the text. And this is how we've done everything. And I think if anyone works with the web and isn't using some kind of virtual DOM, you're in the minority now. It's really, really quite popular. But you have some problems, and this was just the first page that happened to be open. The thing I wanted to point out was if I open this menu, I send an update up to the global handler to say, I want to open the menu. And it says, right, I'm going to re-render the entire page, and then we're going to look at what's changed. And it says the menu's opened, so it re-renders the menu. Fine. The thing that bothers me is how much time it wastes going through the rest of the DOM when I can tell it beforehand that's never going to change. I know up front, I've only clicked that button, nothing else cares about the menu, so why are we even looking at it?
But hold on, that's an oversimplification, right? Because you can...
Correct. Next slide. So, that's an oversimplification, because if you use something like React, you have all these methods. You start separating things into components, and you start adding in event hooks. So you say, actually, I can do things like, when I receive the props, has anything changed that I'm interested in? If it hasn't, just ignore it. If it has, carry on. Problem is, it's not declarative anymore. We're writing this kind of I'm going to call it incremental logic to say, actually, I don't just want to render the view based on state. I want to render the view based on state, and here are some escape hatches I'm going to use to do something optimized. And the thing I'm going to argue about today is that as soon as you've done this, you've lost all the magic and the beauty that is sold to you when you start using virtual DOMs. The idea is I don't have to do this. And now I do, and as soon as you get to any size of application, you can't not do it. Performance becomes so heavily dependent on you using this event lifecycle plugins that you've lost it. You're no longer declarative. So I gave that a kind of slanted frowny face because it doesn't feel right. It feels like we found this beautiful solution to a problem, but it's missing something. And again, as Haskell programmers, I think it's kind of in our nature to say we're missing a better abstraction. There's a better way of approaching this that will solve all our issues. And it turns out I wasn't the only one who had this idea. So anyone who follows PureScript at all will know Phil Freeman's name. He wrote this paper, which is wonderful. I fully recommend you read it. And basically the big reveal was he took the store comonad and changed the position key to say state and the like a variable to say view, and just said all the store is, if I extract it, is take the current state, apply it to a function from state to view, and I get the view. And so he goes on and on and on, and I'll show some examples, and basically goes through kind of our favorite comonads and says they all model pretty perfectly some classic UI patterns that we care about. So if you start with state, you get your pure rendering immediately. We've done React, tick. More machines, to anyone who's used them, are state machines. And we'll come back to this one because it's my favorite. EDSLs are kind of a generalization of more machines to do embedded domain-specific languages. The sum comonad, you have this Boolean that says which side am I interested in, and if you kind of cons list those together, you get a router. You say, am I interested in this page? Yes. If no, am I interested in this one? Yes. If no, am I interested? And you've built a router out of this structure. And day convolution, I really don't have time to go into, but this is, if I have two applications, I can combine their views in a way that they don't interfere. And so the classic obvious one is if I have a split pane, the two sides of that pane don't need to talk to each other. They're just independent views that happen to be rendered together. And so his point was we can stack all these together into a beautiful comonad stack, and we've built a whole UI just out of this. Didn't solve any of the performance problems, but I got really interested in this one, and it turns out so did he, because if you think of update as, instead of events like Elm does, as a change in the state, what we've got is actually a kind of beautifully formed function handle that says if you can give me the change in state, I'll tell you how to change the view. And that's perfect, because if I can tell you how I want to change the view, I can tell you not to bother with 99% of the web page. And this is great, and he wrote at least another blog post about it, if not a paper, and we both got really into it, and then said, this is magic, this is truly magic, everything's a comonad, we can all go home. We've done maths, we've worked out UIs, let's all celebrate. But writing this in code is really difficult, because not everyone wants to work with comonads every day. So I started thinking about how you take the idea, throw away the maths of it, and just boil it down to actually practically what is it? If we look at React as a simplification of the state comonad, sorry, the store comonad, what is this? And so I split it up into several bits and said, I still want to know what the state is, but I want this, and I'm mixing terms again, I'm calling it an update. I want to know the change in state, what's happening. And I called it direction because that's where I can say, this is where I'm going. So a user's clicked a button, I want to filter this table. So I'm saying this is my state, but this is the intent I'm going with. So I can start talking about the changes I'm trying to make, and I can be more explicit about those. I can talk in patches, we'll go over that a bit later. If you can tell me how you want to update, instead of telling you what I want it to look like, I'll tell you the set of things you need to do to get where I want to get. And finally, this update cycle kind of says, if the DOM is throwing events up at me, I want to catch them, translate them into updates, and push them back down. And those updates are attached to an algebra which says, this is how I want to manipulate the DOM, change it, add nodes. whatever else. So I started writing it. And so this is my slightly simplified version of the current component, which says a component has some children, some properties, and a tag name, just as we saw before. But children can be one of two things. You can have static children, which we say they don't change. That key is always present. Or you can have dynamic children, which say I'm listening on update and state, and when I hear something I'm interested in, I'm going to give you an algebra to explain how I want to update. So I might remove some properties, I might add some properties, I might even rename some, whatever I want to do. And properties I've missed off here, but it's basically the same thing. It's just another layer to it. And so the algebra looks like this for components. This is verbatim copied out of the library. So all I ended up doing was saying my state needs an interpreter that can, given an array of state, perform these actions, and then the DOM needs a similar interpreter saying, given this update algebra, I can do these things. Things to note here, there's no access of the values, it's mutation only, which means you can kind of just shove this in a list, in a free monoid, and you can start doing things like optimizations without having to worry about looking over binds or all of the other stuff that anyone familiar with free monads has had to deal with. All that goes away because we've just got an instruction set. And similarly, properties aren't an array, they're kind of like a map, so you don't have a few of these, but very similar idea. So how do you localize changes to specific bits? And the way I decided to do it was say every component that's listening for something has this event system that basically says you can stop me listening with cancel. I might produce some events, and if an update happens, give it to me and I'll tell you what I want to do. There's kind of a missing link here where you give me the DSL, it gets translated into something that produces this handle update function. So it's not quite as liberal as you give me an update and you can fire the missiles or whatever. This is just like the output of that DSL. But that's a lot of types and a lot of code and not very interesting. So I had a demo and it might even work. So here's a big table with a lot of data. If anyone recognizes any of the names, talk to me afterwards, we'll be friends.
I know Bob the Drag
Friend. So you can sort and do whatever else you like. You can even filter or whatever else. The interesting thing here is that there's no virtual DOM going on. Each of these rows has its own listener, if you like, that's just checking to see if any of the updates interest it. So while they're all interested in whether the search term has been changed, they don't individually care about whether reordering has been done, because that's an operation on the actual table itself. So you can start being specific about which bits of your UI care about what's changing. Comes with a few downsides because you now can't be naive. You've got to think about how this all fits together. But again, I'd argue with React, you do at scale. You always have to be thinking about performance and how things are going to operate. And if anyone cares, all the code's on GitHub, but this is how everything works. And this is, I think, the interesting bit, is that if you give me the header you're interested in and which way you want to sort it, the will ascend bit, I'm going to call this function sort by, which I give a predicate function, and it's going to give me back the updated state and a list of moves. So that's my update algebra. And if you go and look at it, I think it's actually pretty boring now. It's not that one. Let's go that one. Cool. This just goes out to an algebra, which may exist. I'm gambling now. Maybe not. Can show you afterwards. Oh no, it's there. 6. Good shout. And all this does at the moment, I'm really sorry, is a really naive insertion sort, and just says I want to generate that set of moves using swaps alone. So swap this index with this index, then move forward, find the lowest, swap that with the front, find the lowest, swap that with the front. But the point is, I don't have to do things that I do in React, like give everything keys, because I don't care anymore what one thing was before, because I'm talking about how I want to change the set as a whole. And hiding all this ugliness behind combinators means I actually, as an end user, never have to care. It's just difficult for me as a library developer because I have to work it all out, and it's horrible, especially because the DOM has some weird properties. An element can't be in the same place twice, but if you always have to insert before, you can't index the DOM. It's disgusting. But yeah, the output of all this is this beautiful table, and everything kind of does what you'd expect. So, whether or not you agree, where are we now, as in today? There are a few things I want to fix before this is anywhere near stable enough to use in any serious capacity. For a start, every element, every property has to register an event system at the moment, and most of them are empty, as in I just don't care, which isn't optimized at all by PureScript. So it means that if I have 100 rows with 4 properties in with 4 elements in each with 2 properties, it just grows exponentially. So that's a relatively easy performance win. And it's not bad now, it's an easy and obvious win. The property update thing, I'm actually not going to talk about because I think I've fixed it. So watch this space. Children and properties, I said, are very similar, but if you go and look in the code, they're still implemented separately. I'm pretty sure I've had a few conversations with that man at the back about how to unify the idea of if you give me an update in state, I'll give you some algebra, and that's how I will update my state. And the other thing, again, Liam's got this library, PureScript Red Panda, which says we can probably write all these components as profunctors, where your kind of contravariance is in the state that's going in, and your covariance is on the events coming out. And if any of you have read any of Phil's stuff, that just does wonderful things with lenses, basically. I can start zooming in on parts of my state for particular components by building profunctors out, die mapping. So it might not be convincing, but I'm quite happy about this. I think it's sound. I haven't found any horrible issues with it yet, and I've been looking. So I invite you, please, tell me this is all stupid and give me a really obvious example of where this won't work. But otherwise, I'm Tom. The library is there as PureScript Panda. All the algebra that I use for the incremental updates is in a separate library. Thank you. Any questions? Hello.
So this is probably a silly question, like I didn't understand anything you said, but what's the programming model like? Is it still view, update, and just that, or is there
absolutely, yeah. So
a lot of extra combinators to deal with components and to deal with diffs? So is it going to be the case that now I have to translate update diffs to view diffs, or is that going to be taken care of for me?
Going to be taken care of. The approach I wanted to take was I wanted to get it as close to the Elm interface of just having whatever it is, view, subscription, initial, and update. And so those functions are still there. It's slightly different because I can do things like async dispatch, which I don't think Elm can do yet.
You can do commands.
Yes, but as far as I know, and feel free to tell me I'm wrong, you can't asynchronously schedule AJAX requests until the next one comes back with a different command that I can read and then fire the next one and things like that. Fair enough. But yeah, essentially when you do the update, you get past this dispatch function, and it says if you can give me a state and an update, I'll just fire that off to the UI and everything will update. So it's fairly close. I can actually show you the exact type. So it's that is the type of an application. It's nothing, like I'm not hiding any complexity. It's that basic. There is some ugliness at the moment, especially around properties, but simply because I haven't had time to sort it out. I think at least the component workflow right now is getting there. It's not quite as pretty as Elm, and that's where I'm benchmarking this. I want it to feel like you're working with a virtual DOM, even though you're not. So a lot of unanswered questions, but I think I'm getting there.
Yeah, hopefully you will put together some kind of blog post or...
Yes, yeah, it's certainly the intention. I kind of wait until it works, which is probably a bad idea. Yeah.
Question on the algebra slide. Is there a CRDT, you're talking about concurrency and being able to fire off asynchronous requests. Is there maybe something like a CRDT that could drop out of this type here?
Absolutely. The only reason I haven't been bothered to do it is that JavaScript is woefully single-threaded. So I've never had to worry about it yet. But I would.
JavaScript gives you the kind of thread-ish things.
Yeah, ish. There are a lot of caveats in terms of actual DOM updates. You know, it's always going to be synchronous. But I would love to try it out. I think it could be done. The thing I'm worried about is when you start talking about CRDTs, you have to introduce metadata, like where's my position at what time, that sort of thing. But I don't see why you couldn't wrap it. I'd be interested to try. Sorry, I will get.
It's possibly another stupid question, but looking at your algebra, and you said you had implemented a naive sorting algorithm. Would every swap get rendered, or does it sort everything and then render it?
Every swap gets rendered. The DOM is, the rendering engines within browsers are actually quite clever about it. They will kind of batch updates within the animation frame, which is, it's good. It's not deliberate on my part. It's just a lucky consequence I found later. I mentioned a bit about optimizing because you can see the full set of algebra. Right now, all it does is say, if I have to swap with myself, don't. And that barely counts as an optimization. But yeah, definitely something that could be implemented. Yes.
Isn't this completely wrong?
And you go for it. I've had one beer. I'm ready.
By initiating this research program of creating this very high-performance engine, aren't you giving engineers the power to build very complicated user interfaces? Whereas in fact, with many DOM elements, whereas in fact,
absolutely,
building much simpler user interfaces that have it gives you much more focus on a smaller number of elements.
So, that's a good question. Yeah. So I get on a soapbox about this. I think we undervalue the complexity of a UI. I think, especially as back-end developers, we tend to assume that all the problems are back-end problems and the front-end just needs to be as simple as possible. And I don't think that's true. I mean, I'm not going to pretend I don't agree with you somewhat, which is why I'm going through the effort of writing all these functions to hide it away. But I certainly don't think, given that you have all the event lifecycle hooks for React, I think we've shown that people don't, at least they don't actively seek to shoot themselves in the foot, right? People don't want, or people aren't naturally inclined to get things wrong on the front end because we design our systems such that they're quite simple. I don't know whether this would change that. I'd be interested to see. But then I'd say at the end of the day, if you just ignore the update property, it's just Elm again. The only thing that this really adds in, apart from Algebra, which again you can chuck out and you can just say throw everything away and render this. The only thing it adds is a kind of direction to your state. So you're always free just to ignore it. And one of the other things I missed out was that you can embed applications within components lower down and existentialize away all of the kind of the state event types and things like that. So you can kind of make black boxes, right? You can contain ugliness. I don't know whether that's a good enough answer for a question that started with, isn't this all wrong? But
it's too much power.
I think all of these components are taking is great from an engineering perspective. But I think you have to, I mean, all this React came out of Facebook. You look at the Facebook webpage, all this stuff like flashing, compare it to the Apple website, compare it to Google interface. These are much simpler and really well designed, not engineered.
Well, so this is kind of my argument for doing it. I mean, we are a glorified form at the end of the day. We try to make it intuitive and friendly and comfortable, but at the end of the day, you've got to collect some information about mortgages. So the page doesn't jump about. It's just, I'm editing this form, this is where I want to care, and then I'm editing this one, this is where I want to care. So I'd argue that actually they're the better use cases for this, where changes are extremely localized, because when you have the whole page, then it becomes complex because you have a lot of this kind of orchestration to worry about. The example that was first given to me was like the message count on Facebook. If I read a message down there, I have to update that. And someone said, now you've got to worry about those two being separate. But you do with React as well, because if I've optimized the chat windows to care about certain things and I forget that that's happening, I'm in the same situation. but we can talk in the pub because this is a great conversation. Hello.
Can we see some of the code that renders that table? I just want to get a flavour for what it's like to write render.
Yeah. So it kind of. So right now, caveat. The property work is disgusting because I thought of a solution this morning talking to Will. So this is all inlined, which I don't really like at all. In terms of, so that, again, so stuff like this, right, is ugly, but it's internals. So there's already a function, I just haven't updated my example, called render, which says you give me a set of HTML elements in this DSL, and I will just generate a thing that says push this to the array, push this to the array, push this to the array, push this to the array. So you never have to see any of that. In terms of things that actually do things like sorting, that whole rendering is done at this point. So that generates the moves, and then, if I can find it without getting it wrong, when I want to do the instruction of actually updating the table, I just run the instructions I'm given. So the rendering is just execute what I've been told. Again, that might be a grisly look into some internals that I should hide away, but I don't hate this, because at that point you can see the instructions, right, in your view. If for whatever reason you have something in mind where you say, if this table's empty, I suddenly want to write something that says, sorry, no results found, or something. I now have that option. I can inspect the updates as they come into the view. Might not be the best place for it. It might be better to hide them away, but yeah, unanswered questions. Hello, right at the back.
Have you seen the Ember.js Glimmer VM and how they use instructions? They look at mustache templates and try to separate the static content from the dynamic content and generate a set of instructions.
There's some really, yeah.
Those instructions somehow correspond to your, like, they're similar to your algebra you have in the instructions you
So
have on screen.
As I understand it, nearly. There's another project called Hyper, which does something really cool with string interpolation. And it says, with the ES6 syntax, I can tell which bits have been interpolated. And then I can kind of set up a sub VDOM on that. So I think, and I might just be talking out my ass, I think the point is it's still virtualized, but with locality. You're trying to solve the problem of 90% of my page is never going to change by introducing these kind of syntactical interests. I don't know that it's the same, and I'm not clear enough on how it works to say.
On Glimmer, it's actually a compilation step. So at runtime, if there's a bytecode, like a bytecode of virtual
That sounds terrifying.
instructions, it's actually a binary bytecode. And
In JavaScript.
In JavaScript, they have written a very small, like it's few kilobytes kind of interpreter. So that then, like, because all these static parts, not the static part kind of logic, normally happens in every browser.
Yeah,
Here
yeah.
there's a compilation step. In that compilation step, because it's not working on arbitrary JavaScript, but mustache templates, it can actually separate them out. And so when you're doing the update, it knows exactly which node to modify.
I didn't know that. I'm going to go and look it up. That sounds sick. I don't know if it works, and I don't know if it's more performant, but...
I don't know what version of sick you mean either. So much modern parlor.
Yeah.
One more question maybe, and then we'll...
Yes.
Well, that's quite early on, but have you run any benchmarks or
I told you to write benchmarks.
This morning. I haven't yet, and simply because as I was writing the slide of ways to optimize, I saw at least 3 I could do in probably a couple of days. So I promise I'll do it this weekend, and I'll get a benchmark sorted. I think when you look at the graph of how front-end libraries perform, you've got React actually quite high up. It's a bit clunky, and then you go right down to like Elm, which somehow, given its like 100 kilobyte runtime, is right at the bottom. So React is where I'd like to be. I'm not too fussed about being close to the metal or something. But I also think you could care about that if you wanted to. If you can find it's a UX problem to solve. How do you make explicit instructions look like something people would want to code day to day and wouldn't think, I'm just going to end up shooting myself in the foot. So again, it's an unsatisfactory answer, but watch this space. I will do it, promise. Uh-oh.
Can I? Just because it's very related to that.
Yes.
There seems to be a lot of energy in the Facebook world about how can we get away from the virtual DOM and do something more performant. But Elm's incredibly performant, and it uses a virtual DOM. So what's going on?
Go for it.
Yeah, that's incredibly performant is immediately a relative statement, right?
Well, you just showed us your own graph with your hands in the end.
Right, but again, it's a relative graph, so we don't know how much better you can do, because if all the front-end libraries tend to be virtual DOMs, we're comparing virtual DOMs against virtual DOMs. We haven't had someone come along and say, actually, I can do this. Like, if you start benchmarking them against some kid who's written it all in jQuery, guarantee he'll be faster, because he doesn't have the overhead. So it's an unfair comparison, I think. The reason we all get excited is because Phil's into it, and he has that kind of effect on people. And I think it's an interesting research space, even if the answer is it doesn't work, it's too ugly, it's not going to be quick enough. PureScript seems to attract people who get given this quite restricted language and then think, how can we break it? Like, how can I warp it in some way that lets me do X, Y, Z without all the features Haskell has?
Let's thank Tom again.
Thank you very much.